Hello and welcome to the Daily Space for today, Thursday, April 23rd, 2020. I'm your host, Dr. Pamela Gay, and I am here to put science in your brains. Now, even though things here on Earth have slowly crawled to a punctuated shelter in place, the universe just keeps on going, spewing out events at a regular and somewhat random cadence. Now, while most observatories here on the planet Earth have shut down, the nice thing is that while we are going to have a gap in our data, that's going to come someday in the future. Right now, we're still in an amazing position where we're able to keep on keeping on with all the data we already have in hand. Now, one of the things that our universe likes to do on a regular basis is merge things. This includes merging black holes together. And just over a year ago, the LIGO suite of detectors scattered across the surface of our world sensed that minuscule contraction in space and time that indicated that two black holes somewhere out there had decided to come together and make one even bigger black hole. This system, gravitational wave 190412, was created through the asymmetric merger of an 8 solar mass-ish black hole and a 30 solar mass-ish black hole. Now, we don't have any videos that create the noise made by these black holes merging, but we do have a fabulous data visualization of what was going on. Now, in a moment, I'm going to imitate the noises made by merging black holes. And I'm going to warn you before I do this that my husband, who I love very dearly, has been making strange noises to attract Stella. And apparently he landed on the noise of merging black holes. So while practicing this morning, every time I practiced it, I ended up with a dog in my face. I may end up with a dog in my face. So here we go. The normal noise made by a pair of similarly massed black holes coming together is a nice, smooth, here she comes. Whereas the noise the noise made by these asymmetric merging systems, first of all, it has more overtones, so more richness to the noise, but it also changes at the end a little bit, where instead of going that normal, it's more like, hi, 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 I see you, I see you. I knew this was going to happen. This, people, is what happens when you do things live on air. So that asymmetry that we detect and that overtone that we detect is what allows us to figure out the differences in mass between these two different objects. Now, here's how I like to think about this. The change in how it ends, I'm sorry, there's someone going down the street and Eddie's just going to bark at them. Live TV, people, live TV. So the asymmetry is due purely to this is two objects of two different sizes. The overtones is more like the sympathetic resonating that you get when a guitar string rings over a cavity and they both ring together, creating these rich harmonics. Well, when you have two different massed black holes merging together, you end up with rich harmonics. It's simply been happenstance that so far the black hole mergers we've detected have been objects of very similar mass. We anticipate there being black holes of a whole variety of different masses all coming together at various points in the universe at various times. And once LIGO gets back to going, we're probably going to detect more, but we might have actually already detected them. The name of this object, GW190412, that means this was detected on April 12th, 2019. And this was the first of I'm going to double check my numbers here. I believe it was 56 objects that LIGO found in its last run that only ended on April 27th. Yes, this was one of 56 possible gravitational wave events that were detected during the last observing run. This is the first one to make it to publication. There are 55 more chances to see black holes doing weird and wonderful things. Now, what's cool about this is it paints a picture of multi-generational black hole mergers. It is thought that the 30 solar mass black hole in this merging system was a black hole that had previously been two smaller, or maybe more than that, smaller black holes that came together. So where we once thought that supermassive black holes were formed through the merger of stellar mass black holes, we're now pretty sure that that isn't what happened. But it appears that this idea of chained mergers is still something that happens. It just doesn't happen on a time scale that allows supermassive black holes to have formed fast enough in the early universe. So there are multiple ways to get at massive black holes in the galaxies of our universe. And that is kind of cool. Now, looking out across our universe, we are constantly finding new and amazing things. And this is not the image I was expecting. So sorry, I'm pulling up my notes. So recently, folks have been doing more and more modeling of how is it that we go from the mixture of mostly tiny galaxies and a few giant galaxies that formed in our early universe, and over time build things up to end up with giant clusters filled with numerous massive galaxies. One of these models is coming to us from a team led by Gupti at Astro 3D, which is a lustrous TNG collaboration. Now, this work, which has now been published in the Astrophysical Journal, is an Australian project that combines a survey of emission line galaxies and computational modeling to try and figure out how it is that galaxies move, merge, build up, and take into consideration the placement of dark matter. So in this particular image that I'm showing you, the bright spots, those are where the optically visible galaxies are located. The stars, the dust, the gas that glows in light that we could see with our eyes, or if it was too far away, through infrared telescopes, because our universe is expanding and it tends to shift visible light into the infrared. The yellow that is overlain and the green, that's the distribution of dark matter. And by working with some of the world's largest computers to combine all this different information, they were able to figure out that massive galaxies, truly massive galaxies, already existed 10 billion years ago, early in the universe. And that the younger, more distant ones, they formed faster than we thought. They combined faster than they thought. And this is an ongoing story of the research that we're bringing you today. So going from this just tantalizing realization that dark matter and galaxies were already coming together early in the universe, we have an observational project put together by the Atacama Large Millimeter Array, where this facility, which has done such an amazing job helping us understand how solar systems form, well, now it's taking on a new task. It's working to help us understand how galaxies form. And working in collaboration with the Hubble Space Telescope, having used data previously taken with the Spitzer Space Telescope, a collaboration of astronomers has been going through and systematically observing nearly 200 galaxies and trying to understand how are they rotating, how organized is that rotation, and what is the rate of mergers early in our universe. And while it's still the early days of this particular study of the early universe, what they're finding is galaxies were already coherently rotating very early on in the universe. And the process of forming galaxies, just like the process of building massive galaxies, every step of this process took place, well, faster than we had ever imagined. The galaxies looked at in this particular survey are being seen only 1 to 1.5 billion years after our universe formed. This means we went from nothing, well, we went from a whole lot of energy and no structures, to having just this diffuse gas of hydrogen, helium, and trace elements at 400,000 years, to within a million years, stars were turning on, to within a billion years, fully formed galaxies were starting to exist. And as we work to understand this more and more, what they're finding is 15% of the galaxies they observed already had ordered, smooth rotation in these early days. And this is just one of those, why is this cool? Well, it's cool because this is not what we thought. We thought it would take a lot longer to form our universe. This has lots of different implications. This means that the structures that drive star formation were already in place earlier than we thought. Now, we also have been learning lately that the elements that make up, well, planetary systems started to be in existence earlier than we thought. And this means that there may be solar systems out there that had potential to have life billions of years before our Earth even came into existence. Our universe worked fast and furious to put itself together. And the question is, what happened before we came about? And since telescopes are time machines, allowing us to look back into the history of our universe as we look at more and more distant objects, we may someday be able to start to piece these things together with the next generation of truly massive telescopes and telescope arrays that are being built, from the overwhelmingly large telescope to the Giant Magellan Telescope to the Square Kilometer Array. All these future instruments are going to allow us to, well, look at these extraordinarily distant systems that, because their light has been traveling for so long to get to us, allow us to actually see the early universe directly. We just need these bigger systems to give us better resolution on that distant part of the universe. And that's all I've got for today. I will now take your questions. As always, this has been the Daily Space. We are a product of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. My name is Dr. Pamela Gay, and I have been your host, and I was the author of the not yet fully written script for this episode. The podcast edition of the show will be very different from what you just heard. If you're not subscribing to our podcast and you sometimes miss the live videos, subscribe to the podcast. It'll be good for your soul or something. You can find us wherever podcasts may be, iTunes, Spotify. Ask Amazon to play us for you. The Daily Space. In addition to me putting this episode together, everything, when it is done, will be produced by Susie Murph. We are a nonprofit project. We live and die by your contributions, but we aren't as important as you are. We understand that a lot of you out there are really struggling right now. And we just want to say, we'd rather you're here as a human and you hang out with us on Discord and you just learn science than you donate money right now. We all just need to find ways to get through. And we want to help you get through. And if you need help, it's your turn to ask us for help. So reach out and let our community know. Do you just need someone to chat? Do you need something more? We're here for you. Okay, so be good, everyone. Be well. And I will now answer your science questions. Larry is like, do not let Dr. Pamela die, never. So I'm not allowed to leave my yard until there's a vaccine, is what I'm being told. So Hanny asks, if there was an unknown force early in the universe, would we know about it? It depends on how early in the universe and what the size scale of the force was. The forces that hold together atoms don't really act outside of the distance of an atomic nuclei. We would be unaware of them except for the fact that we're probing the guts of atoms. So it depends on what those forces might be. Um, Sometimes we just don't know. Oh, we adore you, Topical Trom. We adore you too. And you're making me like, your username makes me imagine warmer times that are yet to come. It's currently a cold and dreary day, and I'm putting my sweatshirt back on as soon as I'm done streaming. It's cold. I may just put my sweatshirt back on. So let's see what else is in here. Hanny asks, does this lend any credence to primordial black holes or primordial overdensities? No. Right now, there's really nothing observational saying that those things needed, that primordial black holes needed to exist. Now, primordial overdensities, these baked in places where there was a little more matter and a little less matter, those we know existed. And those were driven by sound waves reverberating through the early universe while it was still opaque. Those sound waves driven by things like matter and antimatter merging and exploding together and releasing energy that, well, resonated through the early universe. Those sound waves are what compressed the over and under densities in our universe. So Larry asks, I wonder if the cosmic microwave background rotates. Would or could we know? Maybe that makes it anisotropic. So the cosmic microwave background isn't in general asymmetric. It is, as near as we can tell, absolutely identical in all directions. I'm not sure if we would know if it was rotating. I'm not sure the scale size is such that we'd be able to perceive it over the amount of time that we've been around. We don't see Doppler shifting in its colors, though. At least not one that we can't explain with the motion of our own Milky Way galaxy. I don't know. I don't know. That looks like the work of a certain artist, the one who did Marilyn Monroe, the 4-color one. Okay, I'm assuming that we're talking about this. It is a truly beautiful, beautiful image. Are maps like this how scientists find gravitational lenses? Okay, maybe I'm on the wrong thing. Is this what you're referring to there? So gravitational lenses come from direct imaging. This is a combination of images and models to try and understand how you get at things. When we're detecting gravitational lenses, will point a super sensitive, super high resolution telescope. So either the Hubble Space Telescope, which is tiny but above the atmosphere, or something like the Very Large Telescope down in Chile that has adaptive optics on it and is able to compensate for the atmosphere. We'll take one of these telescopes and point at an area where we know there's a nearby large amount of mass. And we'll take a look and look and look and see what we can see. Can we make black hole bourbon balls for community coffee one morning? If you can find a recipe, and for those of you who are at community coffee this morning, I apologize. That was a train wreck. And to give you an extra chapter for the story, as soon as I was done recording that, I went upstairs to start work on the daily space and realized I'd left my coffee downstairs. Went downstairs and discovered 2 dogs had gone counter surfing. Bennu lived, as did one of the other asteroids that I made, but the majority were eaten down by Stella and Eddie. Malachi had gone upstairs with me, and when I yelled at Stella and Eddie, he fled. Stella's reaction was to jump back up on the counter and twist her head to try and reach the two that she hadn't been able to reach already. So, I now know where I can't leave food. That was frustrating. So Hanny asks, what is the max size of a stellar-sized black hole? How much mass was in the original star? So this is where things get trickstery, is we don't know how much mass loss the most massive stars undergo before they go boom. We know that you can end up with baby stars that are order of 100 solar masses, but once they're done forming, they blast material off their surface continually up until the day they die as a supernova. And we just don't know how much mass is given off in that process. So it could be that the maximum size of any one... Sorry, Twitch just glitched. It could be that the maximum size of any one stellar mass black hole is 10, 15 solar masses. And to get anything bigger than that, you have to be looking at merged stellar mass black holes. How much mass loss occurs is really one of those great sources of error in how we model stellar evolution. It's kind of frustrating. Henny also asks, how are these black holes finding each other? I love that idea that the black holes are going through the universe trying to find each other. So it's thought that the majority of them probably formed together. So two massive stars coming together out of one giant cloud of material that fragmented into two orbiting massive stars. They lived and died side by side and now are gravitationally coming together to, well, form a single object after having spent their entire lives together. Now, the other way you can get at these black hole mergers is in particularly crowded stellar systems. You can have objects that come close enough together with velocities that allow them to grab onto each other gravitationally and form a new binary system. So both ways work. We think that the primary way you get at this is through binary stars that form together. But we're still sorting this out. We're still sorting out just how common is it and just how crowded of a system do you need for two stars to form separately and come together later on in their lives. All right, let's see what else is in here. Maybe we can detect black hole mergers by what Stella is interested in at the moment. No. So Larry, what was barely heard in the background earlier today? So Limp Rimple asks, was that a video of your cooking this morning? It was a bad video of it. It was a bad video. I was attempting to cook Rice Krispie treats on camera. It was my first attempt and everything went sideways. I will try again, people. I will get better with time. That was sadness. Thank you, Tropical Tom, for the 100 bits. I missed that earlier. Let me see if I can bring up Doggo Cam in a sensible manner. One moment, please. Yes, I can. That is an overwhelming amount of dog cam, but that's okay. Go get it. Stella is completely asleep and is not entirely sure it's worth it. Stella, go get it. Go get your ball. Go. Stella is up in the chair off camera. I need to figure out where to put dog cam. And she's just looking at me like, seriously? You want me to get down? I was asleep. Stella, get down. Get down. I'm going to throw things at you. Okay. Not going to do it. Whoop. Whoop. You're going to come here? Come here. Come here. She'll come here for that. She comes here for black hole noises. Come on up. Come on up. There we go. There we go. All right. So let me... Here, do you want Cheerios? You need to come here. She's like, no. Nope. All right. There we go. Dog cam. I had enough money left over after selling a bunch of my art and buying gardening supplies that I bought a second light, because it turns out, as much as I wanted to be able to do lighting with a single light, you need two lights. So this chaos over here, that is going to get fixed, I promise. All right, so let's see what we can do. Going back to the science. The Stella call. Is this the new version of marbles? I don't know. Okay, so scrolling back down to the bottom. What is on the floor? Yes, I have a Velcro tie on the floor. I was frantically unhooking dog cam this morning to take it upstairs to use for cooking. And the Velcro tie landed on the floor, and the dogs aren't trying to eat the Velcro tie, so I will pick it up later as I figure out how best to set up dog cam. Hello, Binary Ablaze. Hello. Okay. Stella is full of chocolate Rice Krispies. No chocolate was involved. Black food dye was involved. So she's filled with rice and sugar, basically. Lots of rice, lots of sugar, and some butter. So she's going to have really delightful gassy expulsions later today. Yeah. All right, so as was indicated earlier on, the script for today's episode was not completed prior to the recording of this episode. So I'm going to finish writing the script, I am going to record the podcast, and then I'm going to work on my email. I know some folks have been emailing me this week, and I'm behind on my email. I'm sorry, folks. I'm going to work on catching up. This is on my task for today. As far as I know, no one is planning to launch anything into the sky, and there are no press conferences. So we may not have any planned streams for the rest of today, but we will be back tomorrow with Community Coffee, then Daily Space, then Astronomy Cast. All the things are going to happen. So you guys are amazing. And just to do these standard outro things, first of all, I'm going to work on figuring out my screen. I have got, at some point, there's going to be a stream that is nothing but me figuring out how to make all of my settings work better. I don't know when that's going to happen, but that will happen. All right, so this is me trying to figure out where on the screen I hid the credits. So, as always, this has been the Daily Space. I'm your host, Dr. Pamela Gay, and I will write today's script. This episode will be produced by Susie Murph, and we are a product of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. We're here thanks to you. We're here thanks to your volunteer efforts, to your encouragement, to your words, to your kindness. You empower us to do this. We are very grateful to all of you who have given us bits and subs and who support us each month through Patreon. You allow us to feed Annie and Susie. But right now it's plague times. And if you can't give, that's okay. We'll figure out how to make a go of it. We always do. You take care of you and know that we are here for you. Join us over on Discord. Hang out with us. Play Ticket to Ride. Talk science. Share all of your weird adventures while trapped in your house. We're here for it. So wherever you are in the world, have a fabulous morning, evening, or afternoon. Wash your hands, stay in your house, and be good to one another. Bye-bye.